All right, we're back. This unit is all about arrays. In our last couple of videos, we've been working on a class called ArrayHelper, which is going to kind of be a catalog, a reference. It's a library. It's a collection of methods that you'll be able to use in other programs that use arrays, and they kind of fill a gap that arrays have. Arrays don't have a lot of methods. But if we write our own in kind of a one centralized class that you can copy and paste and move around into other programs and projects, then you have access to them, and it'll help you out in the long run. So picking up from there, we're looking at index of. This method, index of, is going to be in our array helper class. It's going to take in an integer array as well as an integer. Okay, so things can get a little bit confusing here. Write a method index of that returns the index at which the specified int first occurs in specified integer array. Index of should return -1 if the specified integer array does not contain the specified int. What I am saying about what is confusing is that we're looking through an integer array. This is an element that we're ultimately looking for. But what I am returning is the index at which it occurs. Okay. This is mimicking an index of that we have seen out of the string class, right? This was an overloaded method coming out of string, which will allow you to look for either a character or a string, and it will return the index at which it occurs. If it's not there, you get a -1. So we're modeling that, but you just see lots of ints going on, and it's all about context here. This is an element in this context, because we are working with an integer array, right? If this was a double array, this would be a double, but we would still be returning an integer because we'd be looking for an index. Let's get started. I'm in ArrayHelper. I'm going to turn this method signature into a header. We're going to go public, static. We're returning an int. The name of the method is index of. We're going to look through an integer array. I'm going to call that nums, and we're going to be looking for a specific integer. And as I said in past videos, x makes a lot of sense. Let's go ahead and comment here. Returns the index at which x occurs in nums. I should say first occurs. I hope our slide says that, right? The first occurrence, because it is possible there's multiple occurrences. This is still true to how index of worked with string. Returns the index at which x first occurs. So in the case there's multiple occurrences, we get the first one in nums. I'm going to go down a line and add to this, returns -1 if x does not occur in nums. Okay. Yesterday I kind of mentioned how count can mimic some of the behavior that contains does. The same thing is actually true here with index of. This can function like a contains method because it is going to tell us if it's there or not, right? We get a -1 if it's not there. If we get any number that is 0 or greater, that means that x is in nums. So we're going to start looking through nums, and I can immediately start looping. There is no data to store with each iteration. I'm just going to look, right? With each iteration, I'm going to say, is this what I'm looking for? Is this what I'm looking for? Is this what I'm looking for? The moment that I find it, I'm going to return. Right? I'm going to stop there. So no variables in advance needed. We also talked about for each loops in our last video. Unfortunately, a for each loop is not going to be a valid approach here because I ultimately need an index, right? I need integer I. That is very important to the data that I'm looking at. So I'm going to plug in my typical for loop. We'll start at the beginning. We'll go through the end. With each iteration, I'm going to ask, is the current element, that is nums at I, equal to the one that I'm looking for? This looks very similar to count. But instead of tracking it in a variable, I found it. The moment that I find it, all I got to do is return the current index. This is where context really matters, right? There's lots of integers in this context, in this scope, in this iteration. There's the current element that I'm looking at. There's the number that I'm looking for, the integer that I'm looking for. But the one that I actually care the most about is I. This is my index in the context. So I'm going to return I, right? We're looping from the beginning towards the end. With each iteration, I'm asking, is the current element equal to the one I'm looking for? If so, I found it. So I'm going to return I. Not only is that going to spit I back out, right? Output I, we're also going to leave the method, right? We'll stop looping everything. We're done with the method. However, if I manage to go through the whole thing, and this is never true, that means it's not there. So after we're done looping through the whole thing, I can return a -1. Let's try this out. I'm going to flip over to my driver. This is getting messy. So I'm going to actually delete a lot of this. Go back to our original array. And I'm going to do an S out. This is ultimately returning something on ArrayHelper.index of. I am looking through numbers, and I just need a number to look for. Number 4. Easy. Okay, I want you to think for a moment, what index does number 4 occur? Because that is what we should get here in our output, and we do see 4 occurs at 0. Okay, I'm going to look for 2, and 2 is interesting because we actually have multiple occurrences. I want you to think for a moment, which one should we get? This should give me an index of 1 because we were getting the first occurrence. Okay, of note, if you wanted to write this so it is last index of, right? I hinted at a last index of whenever we were talking about string. All you would do effectively is start at the end, right? I'll actually demonstrate this real fast. We'll start at the last element, and we're going to loop towards the beginning. We'll say as long as I is greater than or equal to 0, I minus minus. Now, one area where students frequently get messed up is they put just greater than 0. And that is kind of true to how we typically write the loop, right? I almost never use a less than or equal to. But this is actually greater than or equal to 0 because index 0, there's an element there that I need to access. So we need an iteration on that index. So this is last index of. I'm going to effectively run the exact same code without renaming it. And since there are multiple 2's, I'm going to get the last occurrence instead of the first, and that appears at index 4. That's the only thing that you ultimately end up changing, right? Index of versus last index of. I'm going to convert it back. And a reminder that we could not use a for each loop here because I ultimately need integer I, the index. Let's look at our next method. Write a method max that returns the largest element in the specified integer array. Okay, so we're just taking an integer array, and then whatever's the biggest, that's what we return. I'm going to turn that signature into a header. And, excuse me, I want to document it here. Returns the largest element in nums. Okay, in order to do this, we're going to need another variable. We're going to need to track what is the largest element at any given time. I'm going to loop through nums and ask, is the current element larger than my previous maximum? If it is, we'll update the maximum. If it's not, we just continue on. With each iteration, I'm going to ask, is the current element greater than my largest previous maximum? If it is, we'll update the maximum. If we do that for every element, we're asking, is this bigger, is this bigger, is this bigger, is this bigger? And we end up going through, oh no, that's not what I meant to click. We end up going through the entire array. Whatever is the last value that is in max, that is the maximum. Let me show you. So I'm going to create max, and we'll start it at 0. I'm going to loop through. With each iteration, sorry, I'm going to do nums.length here. With each iteration, I'm going to ask, is the current element, is nums at I greater than my previous maximum? If so, we'll update the maximum. It's going to become the current element. I'm going to get rid of my braces here. If I perform this check on every element, it means that the last thing to be stored in max is the largest. So I can just simply return max. Okay, let's test this out. I'm back in my driver. I'm going to do ArrayHelper.max of numbers. Only one parameter here, the integer array. It can figure everything out without any additional inputs, and it is saying that 33 is the largest. So we're good, right? Little hiccup here in our logic. What if the array is filled with negative numbers? What do you think our maximum is? I'm getting 0. And yet our answer should be what? -1? Let me comment this guy out so we don't get confused. -1 should be the largest value in my array, and I'm getting 0. What's going on? Well, that is because I'm starting max at 0. That's a bit of a problem, right? Because with each iteration, let's bring this in as an example. With each iteration, I'm going to ask, is -4 greater than 0? No. Is -2 greater than 0? No. Is -1 greater than 0? No. No. All these things are negative, right? And so my maximum never gets updated. It will retain its original value, which we set at 0. So this is not a good approach. One thought is, what if we went with something like just really small? I mean, that would get me there, but what if our numbers are all smaller than this? Right? One thing you could do, which I'm not asking that you know this, but one thing you could do is the smallest possible value of an integer. We can go to Google, find out what that is. There is a minimum value that an integer can store in Java. It is based on the capacity, right, of 4 bytes. But that is actually stored in Java in a value that's called integer.minValue. I almost don't even want to show you this because I don't want you to memorize it. I don't really want you to use this. That would work though. This is the smallest possible value that we can store into an integer. So everything that can possibly appear in nums is going to be greater than or equal to this. Okay. What I really recommend you do is set max to the first value. I'm going to start off by saying that nums at 0 is my smallest value. I'm sorry, my maximum value. Right? For our example, that's a -4. I deleted this guy. Let me bring it back. So I'm going to start off by saying that max is a -4. Right? We're going to start looping. I starts at 0. That's his first element. So we're going to ask, is -4 greater than -4? No. So it stays the same. We'll increase I. We're now at the next element. We're going to ask, is -2 greater than -4? Yes, so we're going to update our maximum. It is now a -2. We would do an I++. We're now here. We're still in bounds. We're going to ask, is the current element, -1, greater than my previous maximum, which is -2? It is. So maximum is going to become the current element, which is -1. We do an I++. We're now here. We would ask, is -33 greater than -1? Nope. Is -2 greater than -1? Nope. So the last value that is stored in my max is -1, and that is ultimately what we return. We see that here. Okay, so this is what I do recommend, is actually starting max as the first value, right? It's just one of the values that is in the array, and if we end up with something larger, so be it. Now, there is a little bit of an inefficiency here, as you just saw with that demonstration. I tested max against the first element, right? Whenever I is 0, I'm going to effectively compare it to itself. That very first iteration doesn't do anything with this approach. We can fortunately make it a little bit more efficient. We can shave off exactly one iteration by just starting I at 1. Okay, what this means is I'm going to start at index 1, and I don't even need to consider index 0 because we've saved in a value for max. So this will make it a little bit more efficient. Notice it's not going to change my result, right? I should still get -1 here, but we did shave off an iteration, so it is efficient. The only potential downfall with this approach is if the length of nums is 0. And I'm not even going to worry about that, right? If I send in an array that doesn't have anything in it, I'm going to try to access an index that doesn't exist, and that is potentially a problem. I'm just going to ignore it in this context, but there is some potential workarounds. Okay, our next method is called Subarray. This is going to mimic substring coming out of the string class, right? We're going to take in an integer array and 2 integers. These are going to be indices, indexes. Ultimately, what I'm returning, and we haven't done this yet, is a integer array. Write a method subarray that returns an integer array consisting of all the elements from the specified int array, beginning from the first specified int inclusive to the second one exclusive. Again, just like substring, except we're taking a portion of our array. I'm going to flip back to IntelliJ, and we're going to go public static integer array. This is called subarray. We're going to take in an integer array, and I'm going to specify 2 ints here. One is the beginning, so I'm going to call it beg. The other is the end. I am a big fan of 3-letter variable names, especially when they are descriptive, right? I think 3 letters hits a sweet spot where it's pretty descriptive while also being short, concise. Okay, so let's maybe get an example in here. If I were to call subarray, passing in this integer array, but let's say that we want to just get a subsection of it. I'm going to say 1 to 3. What that should give me back is 4, 6 as an array. Okay, so this original array has a length of 5. What my ultimate result has a length of 2. I want to bump this a little bit. Let's add another value. So if I do 2 to 4, it's a 0, 1, 2. We're going to go 6, 8. Okay, so the first thing we're going to need to do is create the array that we ultimately want to put numbers into. So I'm going to create an integer array, which I'm going to call RTN. And we need to know how long it is, right? At the point of declaration, whenever I construct this thing, I need to specify a length. That's why it's mad right now. So given this example, we see that the length is ultimately 2. The question is, how do we get that number? One idea is, it's just simply beg. That would be incorrect. I want you to think back to substring because this is going to function the exact same way. And I told you over and over and over again that taking the difference of the parameters will tell you the resulting length. Exact same thing here. Okay, so let's just get the mathematical difference of the parameters. I'm going to do end minus beg. We see that end is a 4 in this example. Beg is a 2. So 4 minus 2 is how we get the length of 2. Now when the thing gets created, it's filled with zeros. So right now it's just 0, 0. Okay. This could be a range of numbers, right? It could be 2 to 4. If this is 2 to 5, it changes a little bit. So I don't exactly know what the range of numbers is. We're going to need a loop to basically loop over that section, right? 2 to 4. Maybe I shouldn't have picked even numbers, but that is, why don't we do that? 2 to 5, which will throw in 6, 8, and 10. Yeah, I very clearly want to show that we're getting a range of numbers. This math still holds true, right? End is 5. We're going to subtract out the 2. This should have a length of 3 as a result. Okay, so starting at index 2, 0, 1, 2. I'm going to start at index 2, and we'll go to this one, to this one, to this one, transferring those elements in. So let's create a loop here. I'm going to do for I. Notice I said that we are going to start at this index. Index 2 is telling me where to start. Think about your loop header. What controls where you start? Right here, right? I'm declaring integer I. I want to start I at this index. That index, 0, 1, 2, that is the value of beg. Okay. I want to end here in this example. We're going to start at index 2. We're going to have a length of 3. It's going to be those 3 elements. I'm going from index 2 inclusive up to index 5 exclusive. The exclusive thing is actually pretty easy because we're using the less than symbol. Right? We're going to be less than 5. We'll have an iteration less than 5. This is my loop header. We're going to start at beg, and we'll go up to end. Okay? So I need to get that element, and I need to put it into the array. Right? So I want to update RTN at a particular index. And this is where it gets hard. Let me show you what I mean. This is the original array. And this is RTN. I'm going to take the element from beg, and I need to put it into RTN here. Those things aren't a one-to-one, right? They don't directly line up. I'm transferring the element from here to here. I need it to go from index 2 to index 0. And then I'm going to need this element, which is index 3, to go to index 1. Right? So I need to basically transfer index 2 into index 0. I then will need to transfer index 3 into index 1. I would then need to transfer index 4 into index 2. What's the pattern here? Ultimately, it is a difference of 2, but we're not going to hard code that 2. What has a value of 2? Our answer here is beg. Right? I'm starting 2 in, which is the amount I need to offset in order to get it to go to the correct location. So we'll get to RTN in just a moment, but the element is coming from nums at I. Initially, that's right here. Right? Whenever we establish I, it's there. That is index 2, and I need to get to index 0. Okay. So I'm going to take the current index, and I'm going to subtract out beg. That is the offset amount. We would then have an I++, right, where we would be here. That is index 3. So I'm going to take the element from nums at 3. It needs to go, let's go ahead and update this. It needs to go from 3 to 1. So it is currently 3. I'm going to subtract out beg, which still has a value of 2. We haven't touched beg. It's the original parameter value that came in. So we'll do the 3 minus 2, giving me a 1. I'm updating RTN at index 1 to become nums at I, which is an 8. We would have an I++. We're now here. I'm going to update RTN at 1 minus beg. Okay, I is currently a 5. I'm sorry, is currently a 4. So we're going to do 4 minus our original beg value, which is 2. RTN at 2, that's this element, will become nums at 4. That's this element. That's going to become a 10. We would do an I++, putting us here. We would see that we are no longer less than end. End is that original value. I have populated RTN. My last thing to do is return the integer array. I'm going to return RTN. This one's a bit difficult. I know. This is returning. It returns a subsection. What did I say here? Returns an integer array consisting of all the elements from the first from, I can say beg here because it's right there. From beg inclusive to end exclusive. I'm going to test it out and then probably go through another example. We can leave our negative numbers. I don't particularly care. But I am going to call, this is going to be fun, ArrayHelper. Sorry. Dot subarray. Let's take a subarray of numbers. And I'm going to use different numbers from my other example just to kind of see it with other possibilities. Let's do 2 to 4. Okay, I'm going to tell that to run. You see IntelliJ is highlighting it with yellow. Potential problems, potential warnings. Yuck, what happened here? Think for a moment. What does subarray return? The return type is integer array. I'm trying to print an integer array. We've had problems with that. It was the whole reason that we wrote a display method. I don't want to print this thing. I want to display it. So I'm going to say ArrayHelper.display on my ArrayHelper subarray. This should give me the subsection from index 2 right here up to index 4. We can see that output here. And the length is the difference of the parameters, right? 2 to 4. So why don't we take this in as an example and see exactly what's going on here. Here's the array that we are bringing in. Beg has a value of 2 in our example, and end has a value of 4. Right? That's what this stuff is here. I'm going to create a new integer array, which is end 4 minus beg 2. It's going to have a length of 2. Right now, that integer array is 0, 0. There's nothing in it, but its length is established. We're going to start I at beg. Beg has a value of 2. It's going to be a good idea to go ahead and express this as such. I starts at index 2. That's right here. We'll say as long as I is less than end. It sure is. It's less than 4. We're going to update RTN. It is going to be I, which is 2, minus beg, which is 2. That is a 0. RTN at 0. This value is about to change. It is going to become nums at I, -1. We would do an I++. We're now here. We would ask, are we less than end? Well, the current value of I is 3. That is less than end. That's true. We're going to update RTN at I, which is 3, minus bag, which is 2. This gives me 1. We're going to update RTN at 1. That's this element. It is going to become nums at I, which is a -33. We would do an I++. We're now here. We're going to ask, is I less than end? I is currently 4. Is that less than 4? False. So we would stop there. We would return RTN, which is this array here, and we see it below. That is the subarray. Okay. Let's look at our final method, which is called merge. Write a method merge that returns an int array consisting of all the elements from the first specified integer array plus the second specified integer array. So the idea is we take in 2 integer arrays and we make them 1. Okay. I actually find this one to be a little bit easier than subarray. I'm going to call these things, instead of saying nums, right, I got to name the other integer array. We got 2 integer arrays coming in here. Calling one, nums and nums1 and nums2. I'm going to go with A and B, which is taking a page out of our coding bat variable naming scheme. So I ultimately need to return an integer array, much like we did up here with subarray. I'm going to create it in advance. Right, I'm going to create RTN. It's a new integer array, and I needed to figure out the length. Let's maybe take an example to kind of show what this thing even does. Right, I'm going to merge 5612, that is one array, right? This would be A in the example, along with another array. Let's give that a third value maybe. Right, I'm going to take this array, which has a length of 2, this array, which has a length of 3, and that's going to create a new array consisting of 56, 12, 82, 45, and 68. They become one big array. That's the idea here. So ultimately, RTN, the array that I return, that's this bad boy. What is its length? It's the length of A plus the length of B. I'm ready to start looping. I want you to think for a moment. I'm going to basically loop through A, transferring the elements into RTN. I'm going to then loop through B and transfer the elements into RTN. Okay, seems easy enough. Let's create our for loop. For I, and this one is going to loop through A. Right, loop through A, traverse A. I'm going to start at index 0. And we're going to make sure that we use the correct length, the length of A. Okay, if you look, this is going to be basically a one-to-one translation, right? So A has 5612. RTN is going to be, it probably makes a little bit of sense to do this underneath, where I actually create RTN. RTN is 5 zeros in my example. The length of A plus the length of B. I'm going to take 56, and it's going to go here. I'm going to take 12, and it's going to go here. That directly lines up, right? No offset amount like we saw with subarray. So I want RTN to update. we're doing a direct translation. It's just coming directly out of A at that exact same index. We're doing an I to I translation. So at this point, we have transferred in the stuff from A. Now I need to do the stuff from B. Okay. I'm going to create another for loop. We're looping through B this time. And this is where things get messy, because it is not going to be a direct translation. I need to take B, which looks like this, and this 82 needs to go here. This 45, it needs to go here. This 68, it needs to go here. So this is going to have a little bit of an offset. What is the offset amount? I'm going from index 0 to index 2. I'm going from index 1 to index 3. I'm going from index 2 to index 4. What is the offset amount? The offset amount is 2. What has a value of 2? Our answer here is the length of A actually has a value of 2. So, and that should make sense. We're picking up where A left off. So what I'm going to do is that we're going to update RTN. The element is going to come from B at I. The current element of B, right? We're looping through B. We are going to loop through B here. So I'm pulling the element from B at I. It needs to go, right? If we're starting I at 0, it needs to go from 0 to 2. I'm going to use I so that it updates with each iteration, and just simply tack on a dot length. Right? Initially, I is 0. So we're going to pull the element from B at 0. It needs to go at 0 plus 2, index 2. I'm updating RTN at 2. It is going to be B at I. That's an 82. We would do an I plus plus. I is now here. We're going to do 1 plus 2. That's 3. We're going to update RTN at 3. That's this element. It's going to become B at 3. Sorry, B at 1. It's a 45. We do an I plus plus. I is now 2. I'm going to do 2 plus 2, 4. We're going to update RTN at 4. That's this element. It's going to become B at 2. That's this element. That's a 68. And we'll pick up where we left off from there. I've populated RTN. Last thing we need to do is return it. Let's test that out. In order to do this, I need to create another integer array. I'm going to use initializer list to give it some value super quick. And we're going to do ArrayHelper. I'm going to help us out. Display. Because this method, merge, ultimately returns an integer array. I'm going to pass in the two arrays I want to merge. Numbers and values. This is going to return an integer array, which I then send to the display method, and it gets printed. And there we have the two arrays merged as one. Okay, that is the end of our common array algorithms. We will likely come back and do some for each loops for some of these things, overload them so they take doubles, that sort of thing, to get some more practice under our belt. But I will see you in the next one.